So in addition to arrays, Java has a dynamic list structure called an array list. And the big difference is that you can add and remove elements easily from an array list, where that's a real pain with an array. Essentially, arrays are fixed structures. If you want to change the size, you have to make a new array and copy the old one into it. Array lists, on the other hand, are dynamic. One of the other differences is that array lists take objects, whereas arrays can hold either objects or primitives. So primitives are things like booleans, integers, doubles, and floats. And so far, the only objects we've really seen are strings and some of the built-in objects in Java, like the scanner. Uh, okay. So what we're going to do is we're going to take our sample program that we refactored once before, where we have a teacher inputting grades and we calculate the average, and then we refactored that to add a method that bulletproofs the input, so it loops until the teacher enters valid input, and so the program can't be broken. What we're going to do now is we're going to use an array list to remember the input values, and then we'll display them in addition to the calculated average. So this is a good example of using the dynamic aspect of the array. I don't know ahead of time how many grades the teacher is going to enter. Now, I could actually use an array here instead of an array list. If I did that, though, I'd have to guess at how big the array needed to be. So for instance, I might make the array super big, say 100 records, when I only expect the teacher to enter, say, 25, okay? And then I wouldn't run out of space, but I'd waste all the memory that I allocated for the unused area. So the array list is dynamic. It'll use just what we need. And although we're not going to do that in this program, we could take this further and make an array, a program that would allow the teacher to add and remove records to the set. So for instance, she might have all the data for a test, and then the student is absent, and she gives a makeup test, and now she wants to add that record to the test. She might discover that a student has cheated, and so she wants to remove his record or change it. Okay, so eventually you get to the point where you can create a full database, and of course part of that is being able to store the array between sessions. And we don't really know how to do that yet, although I showed you how you could read files in from the command line, and so you could actually use that method. Later on we'll learn how to do files directly in Java. Okay, so let's go on and look at how the array list works and modify our program to use it. Okay, so let's start by looking at our previous program. I've gone ahead and modified the documentation to indicate that we're about to refactor this. Of course, I haven't done that yet. I want you to see that. So let's just look at this. So we create the scanner, and notice we created the scanner outside of main, so it would have global scope in the class, so I could use it inside the static method. Okay, so my static method getInt is going to prompt the user, I'm sorry, the prompt is in the main code. It's going to go ahead and get the input here if it's available. So if we have an integer available, we'll go ahead and input it in, and then we're done. Otherwise, that means we've got some trash. The user accidentally typoed some keys that aren't going to be a number, and so then we'll print out an error message, and we do read this line in to clear it, but we're not going to do anything with it except show it to the user. Whoops, we should probably fix that. I think we did fix that in a later one. So Tom sometimes has a versioning problem with all these things. So okay, so let's see here. How about you entered trash, you must enter a number. All right, let's do it that way. So I'm going to just add another system out print line here. System, oops, what am I doing? Alt tab, you entered plus trash. Okay, so what that does is that echoes back the bad input to the user so they know what they did wrong, and then it gives them the prompt. All right, it's always good to do that. I'm pretty sure I changed that once before. I must have refactored this before and I've forgotten. I got the different version. Doesn't matter. All right, so now let's get back to the array list here. So let's see. Just want to make sure that my method is going to work here. So here's where we're calling the getInt method. And then the current grade we're going to now add to the array list. So let's define the array list. And the way this works is you have, as usual, the name of the class, ArrayList. Obviously, ArrayLists are objects. Now, this is going to be a little different. We haven't seen this before. You actually have to indicate in a different way what sort of type the array list will hold. And so in this case, we're holding ints. And because this is has to be an object, we have to use what's called the wrapper class, which is actually integer. Okay? So what happens is, you already know that Java has these primitive types, int, double, float, char, boolean. Okay? Those are not objects. We have what are called wrapper classes, which are object representations of those classes. And so integer is the object representation of the int class. And in most cases, they're the same with just a capital letter. So for instance, the integer, the wrapper class for double, is double with a capital D. And remember, we always use capital letters for object class names, okay? So you would expect that this would be int like this, but it's not. It's actually integer. And the only other one that's different like that is if you do char or character, instead of that, it's actually the entire word, character, like that, okay? So again, you should be reading about this in your book, and that'll reinforce that, but I wanted to explain that here in the video because that's the wrapper class for int. And then we give the name of the array list, and this will be grades because we're going to have an array of grades. And then because this is an object, I have to use the equal new syntax to create it. And then this is kind of redundant, but this is going to be the same over here. Well, actually, now in this version of Java, I forgot, you can use what's called the diamond notation. So you just put an open and close, less than, greater than, and then the parens there. Okay, let me make sure I have that right. Let's see. Seems like it doesn't like that. Maybe I've forgotten how the diamond notation works. Let's take a look here at our help. Add import for Java util array list. All right, yeah, so it seems like that's going to be fine. Okay, let me see if this will work or not. Yes, it will. Okay, so you know, Java's gone through several versions, and I think around version 7 we allowed you not to have to repeat the type in here, and so then this became known as the diamond notation because that less than greater than looks like a diamond. Okay, so it can go either way. You can use the old style where you repeat the type here, or you can use the diamond notation. All right, so what I'm doing is I've declared that I want an array list called grades, and I've initialized it. And of course, it's empty initially, right? Now, just a couple of quick things here about array lists. Instead of length, we use size, and that's a method. So grades dot size with the parentheses is the number of items, i.e. the length of the array list. Okay? And then we also have a mechanism for indexing, and that's get. So I would say grades dot get, and that's not going to use the square brackets. It's a method, and then this is going to be the index of the grade. Okay, just like with an array. So this is the equivalent of this. Okay, but you're not allowed to do this. See, this would be for an array. So you can only use this get thing for array lists. Okay, and then you can actually insert into an array list, and you do that by specifying the location. We're not going to need to do that here. In fact, it's kind of important that we get the grades in the order they're given, so then the teacher can look at the list and scan through and check her entry. So we're just going to use the add method to add them in. So again, our array list is called grades. Let's go down here. So current grade equals get int. That calls our static method that we developed down here. And that's just going to return the int. And that might loop 2 or 3 times depending on if the teacher is drunk or having a bad day or something. And if we get our value back, I probably shouldn't have said that, sorry. Don't mean to impugn teachers. I'm actually highly respectful of teachers. I think our culture has some problems there with how we treat them. So anyhow, we're going to add this in, and it'll be like this. So cur grade. Okay? So now, as we go and get the input, we're going to add it in. And now let's come on down here. This is where we check to see if the teacher's done entering the data with the Sentinel. And if it's not if it is the Sentinel, then we're done with the data entry. And then we just go ahead and process the output. So then done is true, and we calculate the average. And right now we just tell how many grades we entered, and we tell the average, right? So let's go ahead and add a loop in here to now display the grades from the array list. And I think what I'm going to do here is use the for each loop. Okay, so for int grade, let's see, and then this really means in grades. So this is called, K. Horseman calls this the enhanced for loop, and a lot of other people call this the for each loop. Some languages actually have a keyword like this, for each, and so Java doesn't. The difference here is it doesn't have an index. So this grade is actually each grade in the array list. And what Java does is it sets up a loop that will go through the array list from beginning to end. So the first time through the loop, grade is really grade position 0, which in an array list would be this get 0, right? And then get 1, then get 2, etc. So this just runs through the entire list, and you can do something to each one. So then we're going to use Alt Tab and come on back here, make that a printf. And so then we want to just print the grades out. So that's going to be percentage, and this is going to be, let's see now. So the grades can have up to 3 digits, so let's make it a 5-character space. And then because this is an integer, we use the D. And then this is going to be grade, okay? So again, this grade variable here will first be the first one in the array list, then the second and the third, etc., all the way through. And now we're going to print that out. And then we want to print a new line here so that this is on a new line and not runs into the grade list. Okay, I think we're ready to go. We did quite a bit of coding here. but I had a pretty clear idea of how to do it, so I think I should be okay. So let me enter this. And let's start by just doing a short correct run. So 12, 23, 45, 56, 78, 89, 90, 100, 100, 100, and then we'll enter a 0, and then now we'll enter a -1 to quit, and there we go. Okay, and this is really nice because you can see the input here. So 12, 23, 45, there we go. And let's see. Grade to quit, -1. You know what? I think I have a logic error in my code where it included the -1 in the array list. So let's take a look. Maybe I put that in the wrong place. All right, let's see. Else done with the data entry. So you see what happened? I added the grades in before I check to see if it's the Sentinel. Okay, so really this code needs to go in here. That's pretty cool logic error. I'm glad that I did that by accident so you could kind of see. So do you understand what happens? I have to check and see if it's a -1 before I add it in to the grade list. That's one of those fortuitous accidents. So that's really good. I showed you a logic error without thinking about it ahead of time. I got lucky. And so now I'll fix that. Okay. So basically, once we check to see that it's not a -1, then we add it to the total of the grades, we add it to the array list, and we increment the number that we're going to use to calculate the average. Okay, let's run it again. And again, I'm just going to try a quick run with no errors. There we go. So now we've got it correct. Okay. All right. Now let's run it one more time just to confirm that our error checking works. I think there's a little bit of a bug where it double loops, and so it gives us a double prompt, but it does actually calculate everything correctly. Okay, there's the error. And now notice, by the way, it says you must enter a number, try again, you entered DF. And then here's where it double loops. You must enter a number, try again. All right, so what do we have? We have 12. You know what? I'm going to do this again. All right. So, well, it looks like it did calculate correctly. The reason I'm going to do it again is I want to use some values where I can be sure that it's actually calculating the average correctly. Now, actually, that looks like enough proof there, but I'm a little skeptical, so I want to make sure. So let me think this through for a second. Basically, if I just enter the same number, the computed average should be that number if it does correctly, right? So let's do this. 75, 75, 75, bad input, then 75. Okay, I've got 5 75s, and now I'll put -1. Oh, I did 4 75s. Okay. And it did say I had 4 grades. Yeah, okay, we're good. We're good. So it does that double loop in there where it prints the message out twice, and I'm not really sure what's going on there. But the counting and the average is correct, so I think I'm going to live with that. And that's where I was before. One of my colleagues might be able to help me with that. I'm probably doing something really obvious. It's just having a brain fart about it here. All right, so I think we're good now on this one. And that's good, about 20 minutes on the video. So again, one of the biggest uses of these array lists is that they're dynamic. If I wanted to do this with an array, I'd have to set the array and I'd have to estimate the size. And so, for instance, I could set it to 100 and make it a lot bigger than I needed. And I'd always end up wasting all the extra space. And if it ever happened that a teacher had 100 or more grades to enter, then it would run out of space. Now, if I want, I can go ahead and go to a lot of trouble and print the logic out that would resize the array if we needed to make it bigger. And you can do that. That's just kind of a pain. So the array list is a lot better. The other thing that the array list is good for, which I didn't show here, is when you want to remove elements. That's a real pain with an array. You have to copy the array. Just like when you want to resize it, you have to copy it. And that's inefficient. Okay, so that's just the basic of array lists. There's certainly a lot more to this part and the types. And of course, I'll explain that in class. So this is just a sample demo showing how to use the array lists for input. Real quickly, if I was inputting double values like currency, again, I would just use the double wrapper class with the capital D. Okay, that's different than the lowercase d, which is the primitive type. All right, I think we're done here. So what do I always say? Code on, dudes and dudettes.